The question that we're going to take a look at is number 41 from section 5.2, which is factoring difference of two squares. 41 will read a to the fourth power minus b to the fourth power. So before you start any of these kinds of problems, you might want to take down a couple notes, okay? These might be helpful to you. So first off, is there a greatest common factor that you can remove from each term? So in other words, you want to go ahead and take a look at your a to the fourth and your b to the fourth. And hopefully you're kind of looking at that and saying, I don't see anything that I can take out. So don't think that you're viewing that wrong. I am bringing this point up just for future reference. It's okay sometimes to say that there is nothing to pull out of each term. So in this case, that is the actual situation. A to the fourth and b to the fourth, they don't have any common factors, so I'm going to leave that. The next thing that you want to check is this a difference of two squares? Well, I do have a difference here, because a difference means subtraction. And then I want to ask myself, is there something that I can square to get a to the fourth? And I can also ask myself the same question, is there something that I can square to get b to the fourth? And we discussed this in class, and some of you had offered up the fact that, yeah, if I square a squared and if I square b squared, I would get a to the fourth and b to the fourth. So with this particular problem, then, we're pretty much all set. So with a difference of two squares, we know that we will get two binomials out. And in this case, we would just split this a squared evenly between the two quantities that we're going to create. So you have a squared squared, which means that you have two a squareds. So let me I'm sure that I'm starting to sound like someone from Wonderland. So let me just kind of write this out for you. A squared squared is the same thing as a squared times a squared. So what I'm saying is I'm going to take this guy and drop him in here, and then I will take this other one and drop him in here. The next thing that we can do is we're going to take a look at b squared, and we can use the same rationale. If I have b squared squared, I can take one of those b squareds and drop him here, the other one here. And last but not least, since this is a negative b squared, one of these must be positive and one of these must be negative. Okay. So always double check to make sure that you don't have any other work left. So right here, I have a sum of two squares. This value is prime. I can't factor this any further. But take a look at what we have over here. I have a difference, and I have an a squared and a b squared. Oh look, it's another difference of two squares. So that means that I can go a little bit further. So I'm going to drop my sum of two squares down. They just go for the ride. And now I can repeat. So how can I break apart an a squared? You guys have answered that question ad nauseum. That's a and a. How do I break apart a b squared? Well, one would be b, and the other one would also be b. But since it's a negative b, one should be positive and one should be negative. Bear in mind, and just to remind you, if you had presented your answer like this, perfect, great, wonderful, I love it. If you presented your answer like this, perfect, great, wonderful, I love it. Okay, so please be aware that the commutative property for multiplication allows you to move terms around. So I could have done a minus b times a plus b times a squared plus b squared. Perfect, great, I love it. So as long as you have these three terms written in here in some order, I'm okay with it. So any of those answers will work. You probably could come up with a few more, but this is the final solution.